Hello everyone and welcome to the Solana Auditors Bootcamp. We are Aki and we are an educational partners of the Solana Foundation. This is the first lecture of this course, and this lecture is going to be dedicated into the introduction of this course and also advanced anchor. My name is Andrei and I'm an auditor and also sometimes developer at Aki. And during this course, I'm going to be also lecturer. On Discord, you can find me under the username Andrei_19. So obviously you can write me DM, but please, for information regarding the bootcamp or questions regarding the bootcamp, use channels inside our Discord. The next person that would like to introduce himself and also tell you more about our company is our CEO. So Joseph, it's yours.
Thank you. So I'm Joseph. I'm the co-founder of Aki Blockchain, and I'm happy that you joined our bootcamp. And maybe the question is, what is it, Aki? So we are smart contract auditors, which means we are providing security audits and assessments. But I always say that a good auditors audit, the best auditors create open source tooling. So we are also trying to contribute in this field, and we are creating very exciting tools. One of them, which will be discussed here in this course, is the first fuzzer for Solana. And also we are very happy that we can be onboarding and teaching a lot of new folks in the blockchain industry. So these are like the three pillars of what we are doing. And regarding the projects we work with, we are very happy that we could be working with some of the industry leaders, such as 1inch, Safe, Axelar, or Mermaid Finance. And we also received grants in the past from Ethereum Foundation, from Coinbase, and of course from Solana Foundation. And thanks to Solana Foundation, you can be also at this bootcamp because it's funded by the Solana Foundation. So thank you, Solana, for supporting such a good initiative, so we can be providing this bootcamp for free for everyone. And I hope you will enjoy it here, and I look forward to the results we bring, and I hope we will contribute to the safer blockchain ecosystem.
Thanks, Joseph, for your introduction. And now let's continue with what is this course about. So the agenda of the course is as follows. Firstly, we are going to talk about advanced anchor stuff, which is going to be covered also within this first lecture. Then we have prepared a lecture about the integration test and unit test. These testing methods are actually really common, not only on the Solana, but on the other hand, they are very important in order to test your Solana programs. Then we believe in fuzzing, so that we are going to have two lectures about fuzzing with Trident. Fuzzing is more advanced testing method. Then we are going to talk about the security best practices, then common vulnerability vectors, both in the anchor context. And last but not least, we are going to, we have prepared the capture the flag, so we hope you are going to enjoy this. What is the goal of this course actually? As we are a security company, we want to teach you a lot of the security on the Solana blockchain, a lot about the anchor security. So that's first part. The second part, we strongly believe in the tooling, mostly in the fuzzing. We also have the Wake framework, which is the Ethereum fuzz testing framework. So yeah, that's why we have actually two lectures about the fuzzing. Yeah, and so last but not least, we would like you to have fun. So that's why we at the end prepare the capture the flag. So if you like to break things, if you like to hack things, we hope that you definitely will enjoy this. On the other hand side, what this course is not about. This course is not about in any means about the introduction to the Rust, about the introduction to the Solana or to the blockchain, to the anchor framework. We are going to talk about all of this probably in this bootcamp, but we believe that you have at least some experience with all of them on some level. So everything is going to be covered in the School of Solana if you want to learn about the Rust Solana blockchain or Anchor framework. That said, let's now just straight in jump into the advanced Anchor framework. So firstly, we are going to touch the Anchor, how does Anchor improves vanilla Solana, what the vanilla Solana actually stands for, what are the differences. Then we are going to talk about the program macro, the accounts macro, and the account macro, how it actually improves the deserialization, or let's say not improves, but make it easier for the developers. Then we are going to talk about the account types. These are really important for the security, as you need to specify correct type in order for the correct checks and correct checks for the account types. That means you need to correctly check what is the account that is expected by the instructions specified within your program. And then we are going to talk about the constraints, which are also super important for the security of your program. These constraints can be used for the accounts specified within the context, so we will talk about them. And last but not least, we are also going to talk about the Anchor idea, as this is also important topic, but more about the security in the previous points, I mean. So let's talk about vanilla Solana. We can say that every Solana program actually has this vanilla Solana format, I would say. There is the difference between vanilla Solana and the Anchor in a sense that Anchor actually improves security of the programs, as it makes it more easier to write Solana programs. You can see that this vanilla Solana RS, it is initialized Solana program without using the Anchor. And you can see there is the entry point, which is which has specified that the process instruction is actually entry point to your program. That means every time someone invokes your program, the runtime will actually invoke this process instruction. This process instruction expects 3 parameters, which are instruction data, so basically byte array, then accounts, which is array of raw account infos, and the program ID. Which is super important is that these 2 fields are completely raw. That means this is byte array, and this is array of raw account infos. So to ensure security in your program, you need to correctly check all of the account infos here. That, let's say, your program expects a third account to be metaplex program, you need to perform such check that the account is executable and the address actually corresponds to the metaplex. And same goes for the instruction data. Your program needs to firstly handle, based on the instruction data, which instruction is going to be invoked, and second has to deserialize actually this instruction data into, let's say, your instruction for swap. If you are working on some kind of DeFi project, your instruction for swap expects unsigned 64-bit long unsigned integer. That means you need to correctly deserialize the instruction data. That's the vanilla Solana. On the other hand, Anchor actually builds upon this, and the Anchor framework makes the development process more easier and also more secure, because you won't forget some of the checks. From the first sight, it might look like this Anchor part, which is basically hello world, freshly initialized Anchor project without any logic. It looks like this is completely different from this vanilla Solana version, but we will see that at the end, these macros, which are program and derive accounts, and also the account macro, expand to version really similar to this vanilla Solana. Just for the context, we are going to talk about in the next slides. Our program specifies this initialize context, which is for the initialize instruction, and the program also supports only one instruction, not multiple, but yeah, it's not that important, just for the context. So let's continue. So what is the program macro actually used for? First point is it encapsulates all the instruction handlers that your program supports. So you can see on the right hand side, this is source code not written by me. This is expanded source code expanded program macro. You can also expand it by yourself. Just create a new anchor program and call within the CLI anchor expand, and it will expand the macros and store the resulting source code in the .anchor folder. So this is not written by me. It is just updated so the source code looks shorter, but it is completely derived by the anchor framework. So encapsulates all the instruction handlers. You can see that the logic starting here is almost identical as for vanilla Solana. So entry point specification, we call entry function, which expects the same parameters as within the vanilla Solana. What starts to be different are these checks, which are again automatically derived by the anchor. So firstly, there is check for the program ID that it actually matches your program's ID. Then there is check that the data len, which is instruction data, is at least 8 bytes. It's due to discriminator of the instructions, which can be seen here in the first function. So, but not just jump into the future. If these checks passes, then we call the dispatch, and this dispatch function actually handles multiple instructions. So you can see on the first line we define sighash variable, which is actually first 8 bytes of the instruction data byte array. Here is the input, and based on the sighash the program handles the instructions. This logic is again completely derived and specified by the anchor framework. So in our case, our program supports only one instruction, which is initialize. So the match statement has only, or in this case it has two, but has only one branch for the instruction initialize. If we support update, there would be second branch for instruction update. We can see there is also handle for IDL, which we will talk a bit later on. So just to sum it up, it encapsulates all the instruction handlers. It encapsulates all the instruction handlers for IDL manipulations. You can see that there are custom errors such as declare program ID mismatch, instruction missing, so it also supports custom error types. This can improve the experience, development and the debugging experience of the Solana programs, as you have better information about where actually the program crashed. And it also works in conjunction with derive accounts macro, which we are going to talk about right now. So derive accounts macro. As I previously mentioned, the instruction or the function that is specified within the entry point macro, the function expects actually 3 arguments: the program ID, the accounts, and the instruction data. Let's say focus on the accounts. I said that the accounts field is expected to be array of account infos. That means this is completely raw implementation of the accounts your program expects. Okay, so let's say you would like to create metadata account for any kind of token you are creating within your program. That is possible. If you want to create metadata using the metaplex, your program actually needs to, or the instruction of your program needs to expect the metaplex metadata program as the one of the accounts in the account info array. That means if you write program using the vanilla Solana or without the anchor, you need to ensure that you perform the correct check for that account. That means if your instruction expects as third account metadata program, you need to check if the account is executable and if the address of the account actually matches with the program ID of the metaplex, which is publicly available in their documentation. I think you can check it also using some of the explorers. This is for the vanilla Solana. On the other hand, you can then also use the Anchor framework, which makes this development process a lot easier because you can specify the context. I will just quickly jump back. You can specify this context. It is basically the same as for the initialize. Your initialize expect this context, which is initialize struct, and within this struct you can specify the accounts that this instruction expects. So as I said, if the instruction expects the metadata metaplex program, you are going to specify it here. This is where the macro comes in handy, because it derives the code that validate the accounts passed to the instruction handlers based on what you specified within the struct. So in this case, let's say you expect the signer, the first account in the account info array should be signer. So it actually creates the signer field and calls anchor-lang accounts try accounts. This function of the anchor actually performs checks that the account is actually signer. Same goes for the system program, but in this case it expects it as a program which should be system program. So it under the hood checks that the account is actually executable and it is system program. So instead of specifying all of the checks for the vanilla Solana, you can just write one line, I mean like pub signer, and you expect the type as a signer, the account type. We are going to talk about this later. And the anchor actually derives code that checks all of the fields you specified. So if it should be signer, it checks that this account actually signed the transaction. If it should be the system program, it checks that the account at this position is actually executable and it's system program. For example, if your program expects any kind of data account, you specify the account with the type, and the derived or the expanded code will perform such check. So, as I said, it validates the accounts passed to the instruction handlers, so to the instruction. It also deserializes the account data. So if you expect, as I said, some data account, let's say kind of escrow or whatever account your program expects, then it can deserialize the account data. Then, this is important, allows specifying various constraints such as init. So if your program or if the context has specified any kind of checks, for example, as here is the example for init, if there is the init, this accounts macro will ensure that the account is actually initialized. So you do not need to do it manually as within the vanilla Solana, but the anchor will generate code that can do it for you. Last but not least, it also generates CPI struct of the account. So if you would like to call your program using the CPI, you can make it as dependency with, I think it's called CPI feature, and you can use these structs. So that's from this derived accounts perspective. Next is account macro. So the last in the chain of macros we talk about regarding the anchor framework is this account macro. And this macro is used for the structures that are going to be stored within the data accounts of our program. The main goal is to handle the serialization and deserialization of the account or of the struct. That means, at the end of the day, the data stored within the account is basically byte array. That means array of bytes, 8-bit long fields. If you have experience with writing Solana programs without the anchor with in the vanilla Solana, you know that you had to handle this manually. So you had to create implementation for serialization from into byte array from the struct and deserialization from byte array into struct. If you are using Anchor framework, Anchor can handle this automatically for you, and it will create derive the source code, so the struct that is using this macro can be serialized and also deserialized, serialized into and deserialized from the byte array. So you don't need to do it by yourself. The second important point, let's say regarding the serialization and deserialization, we can see on the right hand side the source code. This is again expanded account macro, but within my source code I specified that I would like to store this struct in the data account. The struct is called data account, and this it contains one field which is public key, and it is called authority. It is not that important how the struct is called and how the field is called. The important part is that the field is public key, so that 32 bytes. This derive macro here, or this derive part here, is automatically derived by Anchor. And this is the important implementation for the serialization and for the deserialization of the data account. So it actually handles the try serialize function, which is internally called, not that important, but the important part is this first, let's say we were not talking about this in this case yet, but that is discriminator for the account. And then there is the serialization, which basically transfers the structure into the byte array. For the deserialization, it is the same, but in this case it also checks the discriminator. If the first 8 bytes are equal to the discriminator of the account, we are going to talk about this on this slide, what the discriminator means. And if not, then the account discriminator mismatch and you receive the bad account, and then it tries to deserialize the structure basically from the byte array. Now regarding the discriminator, as I was talking about, or we were already talking about kind of discriminator regarding the program macro and the instructions, invocation and handlers. Within the context of accounts, it is slightly similar, or yeah, it might be really similar, but it might create more security risks here. Within the instructions context or handling, you can create, using the simple vanilla Solana version or format, you can just create or expect the first byte is going to be kind of discriminator of instruction. So I was talking about this. If it's 0, then it is you will handle the invocation as initialize. If it's 1, you are going to invoke it, or you are going to handle it as update, and so on. For this account discriminator, it is important because this discriminator ensures that each account your program, each data account your program has, or not each account your program has, each type of data account your program has unique discriminator. This can create, or without the discriminator, it can create security issues, because if the data accounts that your program uses have the same length, let's say 32 bytes, it can also be different fields, but the length has to be the same, then there can be mismatch between the accounts, because the one structure can be deserialized from the byte array as it contains 32 bytes, and the second structure can be also deserialized from the array as it can be 32 bytes. So you need to make sure that you are not receiving or expecting, or on the input of your instruction there is no mismatch between the accounts. That's why we have the discriminator, in order to uniquely distinguish between two account types. Writing your Solana programs, you already may experience this, I wouldn't say behavior, but that's actually when you are initializing a new data account, you specify, it's common, not common sense, it's the common practice to specify the size of the account, something like 8 plus some length. Actually this 8 is for the discriminator. So Anchor will automatically store within the data account at first 8 bytes this discriminator, in order to uniquely distinguish between data accounts. Actually, regarding the source code, you can see within the serialization, here is the logic where the anchor actually specifies the code which will write all, I mean, it will write this discriminator into the first 8 bytes of the data stored within the account. For the deserialization, it is the same, but it is not writing, but it just checks that the data length is at least as long as the discriminator, and if so, then it will check if the discriminator matches. So if yes, then it identified that this data account is correct as expected, and we can proceed with the deserialization. Then this macro also defines the account owner, so you can correctly perform checks that the account is actually owned by your program as it is data account. That's for this last account macro. If you have any questions regarding the macros, just ping me on Discord, or we can create discussion in any channel. Let's talk about the available account types that can be used within the context of each instruction. Just a reminder, you can see the QR code. I see that it's pretty huge, so I might made it a bit smaller. Yeah, so this is only QR code to the documentation, so if you will develop something in the future or audit something, this documentation might be helpful. It's just documentation of the account types, so you might use it. Now you can see the list of the account types. I would say you probably know most of them, but we can go through them. So first is account. I was talking about the account macro in the previous slide. The account type can actually perform the serialization and deserialization actually ensured by the account macro. So that means from the byte array it can be deserialized, then the struct can be back serialized to the byte array. It also checks that the discriminator is correct based on the account type, and then also ownership check is performed. So is the account stores data of your program, so yeah, the account has to be owned by your program. Then there is the account info, which this type doesn't perform any checks. So account info, account loader, it ensures the zero copy deserialization, so no overhead with copying stuff. There is box type, which actually does not perform any checks. It only ensures that the field is actually allocated, or the content of the field, the struct, is actually allocated on the heap, not on the stack. That means, let's say your program uses data account which store all of the lot of data, and the stack is not big enough to store all of the account data on itself. Then it means instead of storing the data on stack, the data will be stored on heap. So that's box type. Then there are interfaces. First is interface, which is program validation, but from the set. That means instead of, I will describe it on example. For the good example is token and token 2022. Token 2022 is basically extension of token, and so if you would like to support not only token 2022, but you would like to in your program support both, you can define the token program that you expect within your instruction as interface. That means instead of checking for exact program ID of token or token 2022, it will check for the program ID from the set, in this case for the token and the token 2022, so you actually support both of the programs. Same goes for the token account, but in this case the ownership is from set, so that means, let's say for the mint and token, you don't want to support only mint accounts and token accounts from the token or token 2022, but from the both programs. So you can specify, instead of expecting the type as account of mint, but you can expect it as interface account of mint. That means you are expecting, or you are supporting all mint from token program and from the token 2022 program. There is the option. This is almost the same as box. Instead of option is not allocating anything on the heap, it is just saying that the account is optional, so it may be specified, it might not. When it's not specified, actually it's none. If it's specified, then it contains something inside the option, which is then the type inside the option is based basically on the inner type, so let's say account. Then the program, which is kind of similar to interface, but this time program validation is not from set, but it has to match exact program it expects. So let's say in this case system program or Metaplex program and so on, or maybe token program, but only token program, not token 2022. Signer, I would say pretty self-explanatory. This is like the most common type, I would say. Then we have a system account, which is, I would say, not that common, but this account specifies or checks that this account type checks that the owner is system program, so let's say regular wallet. Then we have sysvar, which is system variable, and this type checks that actually the account is system variable and deserializes it. And then we have wrapper around the account info, which is unchecked account, and it is like more verbose option to say that there are no checks performed on this account. So it is basically raw account info, and either you are passing this account to the next instructions, to the next program where are the checks performed, or you are going to perform check in your program but manually in the instruction. So these are the account types. We can move on to the account constraints. These are split into two sections, let's say. First section is about the normal constraints. Second section is about SPL constraints, so you can use also constraints for associated token account, and mint. Reminder, there is also the QR code into the documentation of this constraint, so you might find it helpful in the future during a kind of development process or during audit, if you would like to check exact meaning of the constraints. So let's quickly go through them. So firstly, signer. This checks that the account actually signed the transaction. It is similar to the signer type, and I would say the signer type is more common. Then there is mutable, or in short mut, which specifies that the account is actually mutable and can be the data in the account can be changed. Then we have again common constraint init space and payer. This will initialize the account. Payer is going to pay for the rent, and there is the space that is going to be allocated. In this case, you can see there is 8 plus 8. From the previous slide, I was talking about the discriminator, so in this case you can see it as first byte is for discriminator, and the second, first 8 bytes are for discriminator, and second 8 bytes are for data field stored within the account. Then we have init if needed. For this constraint, there are some security issues which we are going to talk about in the future in common attack vectors. So that's why this this constraint is actually behind the init if needed feature. And yeah, you can initialize account only if the account is not initialized yet. And you can obviously specify the spare and the space that has to be allocated if the account is not yet initialized. Let's continue. Then we have the seeds, which is pretty common for the PDA derivation. One interesting fact here is that instead of, you probably know that one of the seed for the PDA derivation is program ID. In most cases, this is going to be your program ID, as you are going to specify PDA for your data accounts, but optionally you can see that you can specify also other program for PDA derivation, so you can expect or you can support also program derived address from or owned by different program. Has one is pretty common for the security checks. This constraint actually checks that your data account has this field, and it checks if the field matches with the authority specified inside the context. This means if your context contains account field called, or account which is called authority, and let's say it is a signer type, then within your my data you need to specify authority, let's say pub key, or in this case if you would like to compare it to signer, then yes, it has to be pub key. And if you specify this as one, it is like the shorter version of specifying full constraint that authorities, the signer's key matches the authority stored within the account. So this is like more shorter option to check that these two fields matches. Then there is the address constraint. This is, like, I would say, pretty self-explanatory. It just checks that the account, the address of account equals this ID specified within the constraint. So in this case, it is create ID, but it can be whatever pub key would like to check it for. Then we have the owner check. We can check that the data is or the account is owned by some particular program. One interesting fact here is that you can, and this is also for all of the remaining constraints, you can specify the error that is going to be shown if the constraint is not like fulfilled. So if the constraint fails, then it will show this error. Then another normal constraints, executable. This is not that common constraint, but yeah, it can be used. But I would say more often you will see the program type with some kind of specified program or interface. Then we have rand exempt, which is also not that common, as currently all of the Solana data accounts, or all of the accounts are required to contain rand exempt. So that's the rand for I think 2 years. So, but yeah, for some temporary accounts you might need this constraint. Then there is 0, which tells that it won't perform the discriminator check. This is also not that common constraint. And we have this is not last because we have one remaining slide, but there is close constraint which will actually close the data account. I highly recommend to use this constraint instead of closing accounts manually, because if you are closing accounts manually, there is also a security issue, I would say. You can create with incorrectly closing the account, so I will highly suggest to use this constraint. But yeah, there might be cases where you are not able to use this constraint, so then you need to close it manually, but use it, I would say, as much as possible. And finally, last but not least, last two normal constraints, we have constraint, which is I would say this can be whatever constraint you want. You see that within this example, the constraint is specified such that the one which is the my data account, or data account storing my data struct, checks that some kind of field is equal, some kind of age field is equal to 2.apple.age, where 2 is another my data account. Then we have realloc, which can be used for reallocating the space that is that the data account is allocated for. So let's say your data account data part is allocated for 100 bytes. You can with this constraint you can reallocate and increase the size of the data account. So these are the normal constraints. Now let's talk about the SPL constraints. On the slide you can see basically the three account types that the SPL constraints can be used for. First is the token account, which as you know stores tokens. I mean, like the token amount, it has the owner, and you store your tokens here for the corresponding mint account, or for the corresponding mint, or we can also say for the corresponding token. Then in the middle is the mint account, which corresponds, as you know, to the token. And then on the right hand side you can see the associated token account, which again you already know that this associated token account has its address associated with the owner and the mint. That's why it's called associated. And yes, for these types you can also specify the constraints or use the constraints. Moreover, you can use these constraints also with the normal constraints that I showed you within the previous slides. So for example, you can see that for the token account you can use payer, you can use init. If you are initializing the token, you need to specify the mint for which the token is going to be initialized, and the authority that is going to have like the authority over the token account. Then, for example, you can also mix it with the previous constraint. Let's say for example with on this slide with the constraint named constraint. And you can check that the token amount is actually greater than some maybe instruction parameter amount, or let's say if you are working on swap and someone wants to buy some amount of tokens, you can use this instruction input parameter to check that the token account has actually more than this amount that the user would like to buy. Then for mint, basically this is the same, but yeah, as you know, the mint has different fields within its account as the token account has. So you can see that there is, for example, the decimals places for that's set to 9, which is like the most common number, I would say, on the Solana. And then, or maybe just not to forget, you can set also the freeze authority and other fields for the mint. And then the associated token account, if you want to initialize the associated token account, then you need to specify the mint and the authority in order to check or in this case is in order to derive the address on which the account is going to be initialized. If you are not initializing the associated token account, then you just or if you want to check the address, you just specify the associated token mint and the authority, and in the background Anchor automatically derives the PDA for this associated token account and checks that the address is actually correct. This is really important in order to correctly audit the smart contracts, or sorry, in this case programs, because in order to correctly audit the program, you always need to check that the let's say the mint is correct, or the authority is correct, or the decimal places are correct, and so on. So it's the best practice to be also familiar with these constraints, and to also know that this constraint can be used with also the normal constraints. You don't need to necessarily need to know every part from your head, but at least you should be familiar with every type, or every type of the constraint, and fully understand it. Now we can continue to the last part of this lecture, which is going to be dedicated to the Anchor IDL. The IDL stands for Interface Definition Language, and in principle the name is actually pretty self-explanatory. It's kind of standardized JSON schema that is used as an interface definition language. So in order to know how to communicate with your on-chain Solana programs, you can define this IDL and use this JSON schema on your front end, let's say, or you can upload it on chain. I was already talking slightly about this. I think it was on this slide dedicated to the program macro, and you may notice that there was logic, or in the dispatch function there was a branch for the IDL logic. This is actually because the Anchor automatically derives the logic in order to deploy this IDL on chain. I do not know exactly all of the source code derived by Anchor, but yeah, you can check it. There is the logic, or you can check how Anchor actually, let's say, derives the address for the IDL account. It's pretty simple. There is deterministic seed. I would say it's something like Anchor-IDL, I would say. And yeah, then for your program, this IDL is created, which is like the interface. It contains all of the informations, or important informations, that can be used to communicate from the front end with your Solana program. And then this JSON schema, then this JSON file is actually as binary stored within the account on chain. You can see on the slide that basically, as I said, the IDL file includes detailed information about each instruction. So as you probably know, the instruction at the end, if you maybe tried to listen or tried to fetch latest block, for example, from the CLI, you could see that the instruction at the end is just the array of bytes. And this IDL can help with that, because the array of bytes can be, let's say, deserialized into some unsigned 64-bit longs, not integers when it's unsigned, into unsigned integers, and or maybe some other structs or custom types. So in order to know what to expect on the instruction input, or what to actually send to the instruction input, you can use this IDL. Then there is also provides a description of each account type used in the program. Again, I do not know exactly all of the fields but it is really important to know about this feature. You can check it with the SolScan or other Solana, or let's say with SolScan, Solana Explorer or other explorers, and you can see that there is the IDL stored within the account. Not only, not every program actually has this IDL stored on chain, but some of the programs have. So you can see basically the logic, you can see the accounts that the program uses to store data, and so on. Last point is about front-end applications and other client tools can use the IDL to interact with the Solana program without needing to manually define the program's interface. Basically, as I said, so the clients and the front ends can with the IDL know how to interact with the programs, what to expect, how the data accounts actually, the layout, how the layout of the data accounts actually looks like, how to try to parse the fields, and so on. In the QR code, this QR code points you to the Anchor documentation, into the IDL part, or into the IDL part dedicated talking about the CLI IDL part, how to create the IDL account, how to interact with it. There is kind of logic, how to set authority, how to upgrade it, and so on. So this is pretty important, not from the, I would say, security perspective, as you do not need to audit the IDL, but yeah, you should be familiar with that. As you could see, that the program the Anchor automatically derives this part of logic from its macros. So when you read the expanded macros, sometimes in the future, you should be familiar that this logic should be there because it is automatically derived by the Anchor. So to recap this lecture, in the first three, let's say, not slides, or yeah, we can call it, let's say, in the first three slides, we were talking about, like, I would say, the most important macros that are available from the Anchor framework. These macros, or we were talking about in actually what these macros expand. That's important. As you are auditor, that does not only mean that you now read all of the constraint, you read all of the C-level attacks available somewhere on the GitHub, and you can audit. From our perspective, the good auditor actually understands a whole program, not only just that you should check the owner, you should check that it is not possible to reinitialize the account, or you should check that this program account is correctly checked and there is no such thing as kind of CPI vulnerability. I think the good auditor actually has to understand all of the whole program, and I oftentimes has to expand some programs and check what actually is done inside the context, or inside the try accounts functions, in order to correctly check if everything is correctly checked and if every check is performed correctly. So that's why we were talking about this expanded code. Then definitely the account types, and I said it is not enough to just learn the constraints, but yeah, we were talking about the constraints and types because on one hand side it is not it is not enough to just know them, but on the other hand side it is important to be familiar with all of the types and constraints, so you know, or you can expect whatever type within the audit, you can expect whatever constraint within the audit, because you know the constraints, you know the types, so you know what to expect, how the types behave, how the constraint behave. You know that there is something like SPL constraints, you know that there is something like normal constraints, and so on. Lastly, I think there are, or we think there are a lot of materials about the interface definition language. That's first part. The second part is that the ideology is actually defined and then or derived with the anchor macros. So that's definitely important to be familiar also with this part. As I said, in the future you may try to expand some program, and you will see that there is the ideology, and you are going to ask why is it there. So you should know that it is derived automatically by the anchor in order to store the ideal on chain. Lastly, I have the anchor expand. That's apart from the information about the macros, expanded code, all of the account types, constraint, and so on. These types, constraints can be found in the documentation, so at least you should understand all of them. But this anchor expand this anchor expand command is actually maybe the one thing I would like you to take from this lecture as the first place, because this can be really useful. If you do not know what is actually happening in the program, or you are not sure what is actually happening in the program under the macros, you can use this command. You can check what the expanded code looks like, and then based on that you can audit or continue with auditing the program as you have better understanding of the program. At the end, if you think about it, this expanded code is then compiled to the binary, to the SBF target, and this binary is then deployed on the mainnet. So you are actually, if you are looking at the not expanded program, you are looking the macros will be eventually expanded, but I would like to say, like, if you are looking at the expanded program, that means you are looking at the final version before the compilation. So you have all of the information that is possible to obtain, like, from the program after the expansion of the macros. So I found this anchor expand command really helpful. Maybe one last point. For example, we have the trident fuzzer. I multiple times already used it also for the fuzzing, so this is really great command. This is all for this lecture. Thanks for your attention. And for the next lecture, you can look forward to the lecture about the unit tests and integration tests. I would maybe say that these are slightly underestimated, as the testing is really important. So yeah, thanks for your attention, and see you at the next lecture.